All right, welcome and thanks for joining us. So this video is discussing the final question from the Doppler worksheets, talking about a car and an ambulance driving both towards each other and looking at the resulting frequency shift. So in this question, it's unique because we have both the source and the observer moving. We generally have two equations that we work between. So we would have that the shifted frequency is equal to the original frequency multiplied by this this ratio here of v over v plus or minus the velocity of the source. Or our second equation was that the shifted frequency was equal to the original frequency multiplied by the velocity plus or minus the velocity of the observer over v. So we've got two equations here. In this case, what you kind of need to figure out is that actually when both are moving, we have a new equation that comes as a result of both, and that the frequency shifted is going to be the original frequency multiplied by v plus or minus VO, the observer's velocity, over v plus or minus Vs, the velocity of the source. So now what I always like to think about is how do I determine the plus or negative here? Remember that this whole section is being multiplied by my original frequency. So if the motion of the observer and the source should cause the shifted frequency to be a larger frequency, then I need to make this as large as possible because it's going to be multiplied by my original frequency. If by some chance the motion of the vehicles or the motion of the observer or the source is going to result in a frequency that's shifted down, so a lower frequency, then I have to make this less than 1, as small as possible, so that when I multiply it by my original frequency, if I multiply it by something less than 1, it'll make a smaller number. So in this case, we have two cars driving towards each other. So if I have one vehicle, and I have an ambulance, and they're driving towards each other, what's going to happen is as the ambulance emits its siren, it is also moving forward, and those waves are going to stack up because it's going to, every time it emits a wave, the next wave it emits, it's actually moved towards the previously emitted wave. So it's stacking the waves. At the same time, this car is going to be moving towards these waves that are coming at it. So it's going to hit them more frequently than it would if it was standing still. So both of the motions are actually contributing to a higher frequency. So I want to pick numbers that are going to make this as large a number as possible. So to make this large, I want a large numerator and a small denominator. So I'll say that again. So because I know that both the car, the observer, and the ambulance, the source, are moving in such a way that I need my frequency to shift higher, because I know this person's going to hear a higher frequency, I need to make this this ratio here as large as possible. So I'll start with the numerator. V plus or minus VO, the velocity of sound plus or minus the velocity of the observer. To make this as large as possible, I want to pick plus. V plus VO. Now also, whatever number I have in the numerator, I want to divide by something as small as possible. The larger a number I divide by, the smaller the number becomes. So I want to divide by a small number. I don't want to divide by a big number. So I'm going to actually pick the minus. So what I'm left with as my equation is that my shifted frequency is my original frequency times the velocity plus the velocity of the observer over the velocity minus the velocity of the source. And even this should seem understandable because if we just had the source moving, we would have gotten to the equation v over v minus vs. Had just the observer been moving, we would have had v plus VO over v. So we've just combined the two. Now it's time to put in the numbers here. So in this case, the frequency is going to be my original frequency, 520 hertz, times, we weren't given a speed for sound, so we're going to assume 343 meters per second, plus the velocity of the observer. The car is traveling at a speed of 50 kilometers per hour. Oh, but be careful. We can't use 50. Kilometers per hour and meters per second are not the same thing. So, we want to convert that. 50 kilometers per hour. Sorry. 50 kilometers per hour divided by 3.6 would give us 13.88 meters per second. And on the bottom we have 343 minus 65 kilometers per hour. With 65 kilometers per hour is going to be 18.05 meters per second. Just to explain the 3.6 quickly, to go from kilometers per hour to meters per second, I would have to go from kilometers to meters, so multiply by 1,000. Then I have to go from hours to seconds in the denominator, meaning divide by 3,600. So multiplying by 1,000 and dividing by 3,600 is just like dividing by 3.6. It's a quick trick there for you. So now if I was to do this part, what I'm going to be left with is 520 multiplied by, in my numerator, 356.88 over, I'm going to use a calculator for that one, 343 minus 18.05, 324.95. Okay, so quickly doing this now, 356.88 divided by 324.95. There's my ratio there, multiply that by 520. I get 571.09, but based on significant figures, we're just going to use only 2 sig figs. We only have 2 sig figs ever in the question. So 570 hertz. And that's the final answer for part A. Part B is after they've passed each other on the road. So after they've passed each other, is going to be, we have to make this now as low as possible. If the ambulance and the car are moving away from each other, in this case, now we have the car going that way, and our ambulance going that way. Every time this ambulance emits waves, the next wave it emits will be further back. It's creating more distance between the waves, and this car is driving away from the waves, so it's going to get hit less frequently. So both things we know together result in a situation where the waves have to be a decreased frequency. This shifted frequency has to be lower. So we have to multiply our frequency by something less than 1. So we want to make this fraction as small as possible. So V minus VO will do the job on top, and V plus VS will do the job on the bottom. So filling in the numbers here, that becomes 520 hertz multiplied by 343 minus 13.88 over 343 plus 18.05. I'm just going to solve this through. So 343 minus 13.88 gives you 329.12, and 343 divided by, plus 18.05 gives you 361.05. Now, that ratio, one over the other, 329.12 divided by 361.05 gives us 0.911. So just to stop for a second, it was interesting to note that this ratio here gave us about 1 point something. It was 1.1, or I can't quite remember. You can go back in the video to take a look. Now when we switch the signs, we get 0.911. So ironic, I actually really didn't choose that 911 would be the number we get for an ambulance-related question, but there you go. So when we take our original frequency and we multiply it by 0.911, we're lowering it, whereas when we multiplied it by a number larger than 1, we raised it. So multiply this by 520, and we get a frequency of 470 hertz. Again, rounded to two significant figures. And that would be the frequency after. So, interesting to note that between the two answers, there's a 100 hertz shift in frequency. Thought that was pretty cool. So, hope you enjoyed. That's how you do the source and observer moving Doppler effect. Thanks for watching.